So welcome friends in my channel. So today we are going to start a new chapter, that is boards and streams. So this is a common chapter of arithmetic in any government job examination. So without wasting any time, let's understand the chapter. And by the way, I will cover some problems and show you some detail and short form as well. Okay, so let's start. Okay, so we have boards and stream. Now let firstly just understand the concepts. Okay, so let the speed of a boat, let the speed of a boat say that is x kilometer per hour, and the speed of stream, that is y kilometer per hour. Okay, so this boat you can consider is as a person also. Okay, so this can be a boat or a person. Okay, so let the speed of a boat or a person is x kilometer per hour and the speed of the stream is y kilometer per hour. Then our first term is upstream speed. Then upstream speed gonna be x minus y. It means their directions are opposite. If boats go in this direction, then the stream goes in this direction. They are opposite. So if the boat and the observer, boat or observer and the stream are in opposite direction, then it is called upstream speed, and this is represented as x minus y, that is the difference of their speeds. Okay, now if they are moving in the same direction, okay, so if they are moving in the same direction, that is if boats is moving in this direction, then stream is also moves in this direction, then in this case the term is called, that is downstream. Okay, and downstream speed will be x plus y kilometer per hour. Here is also, that is kilometer per hour. So when the boat or the observer and the stream are in the opposite direction, that situation is called upstream, and the speed is called, and the relative speed is called upstream speed, and they represent as their difference of their speeds, that is x minus y. And if they are moving in the same direction, that is if the boats go in this direction, boats or observer is going this direction, then stream is also goes in this direction, then this situation is called downstream speed, and in this case we can represent the relative speed as their addition, that is x plus y kilometer per hour. Okay, so this is the basic concept of this chapter. Now let's begin to our problems. Okay, so by doing the problems you can understand the whole concept of this chapter. Okay, so let's proceed to our first problem. Let me fold the paper, otherwise it out of the frame. Okay, so our first problem is, that is speed of a man is 10 km per hour in still water, and if the rate of the stream is 3 km per hour, then what is upstream speed and downstream speed? Okay, now we have the speed of the man is 10 km per hour. So we say before that this man can be an observer or a man or a boat. So we let x is equal to, that is 10 km per hour, that is it can be an observer or boat. So here it says that is observer or a man. Okay, and y is called, that is 3 km per hour. Okay, that is y is that is stream, that is rate of stream. Okay, now we have to find out the upstream speed. We know upstream speed means they are in the opposite direction. This means the relative speed should be x minus y, then it calls 10 minus 3, it means it 7 km per hour. Okay, so this is the upstream speed. Now if we say that is a downstream speed, so downstream speed should be x plus y. The downstream speed means they are moving in the same direction. This means the relative speed gonna be 10 plus 3, that is 13 kilometer per hour. Okay, so this is our first problem and our first concept. Okay, this is exercise 1. Okay, now move to our next problem. Okay, so our next problem says, okay, so it says that a man can row upstream at 10 km per hour and downstream at 16 km per hour. Then find the man's rate in still water. Okay, so firstly we have that is detailed method. Detailed. Okay, so detailed method, in detailed method, let the speed of the man, let's say x kilometer per hour, okay, and speed of the stream, say y kilometer per hour. Okay, so it says upstream speed is 10 km per hour. It means x plus y means 10, and downstream speed, it means x minus y, gives us 16 kilometers. Sorry, x plus y is 16. Sorry, downstream is 16 and upstream is 10. Okay, upstream is 10 and downstream is 16. Okay, now by solving this we get y cancel out, we get 2x is equal to 26 and x means 13, and we have considered that is x is the speed of the man. So our answer is x is equal to 13. So the speed of the man is 13 km per hour. Now let's move on to the short process. Okay, so in this case, if x is the man's rate in still water, okay, if x is the man's rate in still water, then x is equal to half of man's rate, x is equal to half of man's rate with current means stream, I say that is stream, plus against stream. Okay, so the formula is x is equal to half of man's rate with stream plus against stream. So it gives us half of man's rate with stream, that is against stream tells us that is it is 10, and upstream is called, that is man's rate with stream is 16, which means it gives half of 26, that is 13. It also comes 13. So this is the short process and this is the long process, we say. That is, this is the formula, that is x is equal to half of man's rate in still water, that is man's rate in with the stream plus man's rate against the stream. If we plus it and divide it by 2, we get the answer. Okay, just look it out carefully. Okay, now let's move on to our next problem. Okay friends, so our next problem is here. That is, a man can row upstream at 10 km per hour and downstream at 16 km per hour. Find the rate of the current. So we have to find out the rate of the current. So this problem is a little bit similar to the previous one. Okay, so first is the detail method, that is let speed of the man is equal to x kilometer per hour. Okay, and speed of the stream is y kilometer per hour. Okay, then we can say that is x plus y, that is downstream speed tells us 16, and x minus y, that is upstream speed, gives us 10. Okay, now they are quadratic equations. Let's solve them. That is x minus y plus y minus y cancelled out, and 2x gives us 26 and x gives us 13. So we have to find out the rate of the current. So we have to find out the value of y. Now putting the value of x to this equation, that is number one equation, that is x plus y is equal to 16. It means 13 plus y is equal to 16, that is y is equal to 3. Sorry, this is not 23, this is equal to, okay, so y tells us 3. So we have the rate of current, that is y is equal to 3, that is 3 kilometer per hour. Now let's move on to our short process. So let if y is the rate of current means stream, then y is equal to half of man's rate with current, with stream or current, minus against current. Okay, so y is equal to half of man's rate with current. It means it is 16 minus man's rate against current, which gives us 10. That is half into 6, which gives us 3. Okay, just check it out. This is also comes 3 and this is also comes 3. So this is the short process, that is y is equal to half of man's rate with current minus against current. Okay, then by solving the algebra we get the 3. Okay, so this is our third problem. Let's move on to our next problem. Okay, let me fold the paper. Okay friends, and this is our next problem. So this tells a man takes twice as long to row up as to row down the river. If the rate of the river is 4 km per hour, find the rate of the man in still water. Okay, so in this case, let me elaborate the detailed method. So let rate of the man in still water, that is x, then upstream speed should be x minus 4. Why? That is the rate of the river is 4 km per hour, so upstream speed should be x minus 4 km per hour. Okay, and downstream speed should be x plus 4 km per hour. Now it says the man takes twice as long to row up as to row down the river. So according to the question, we can say that is x plus y is equal to 2 into x minus 4. Okay, so x plus 4 is equal to 2x minus 8, which means minus x is equal to minus 12, that is x gives us 12. So we have the answer, that is the rate of the man in still water is 12. Okay, that is 12 km per hour. Now let me introduce to you the short process. Okay, so in this case, if we consider that is the rate of the river x, that is 4 km per hour, and the twice, that is the number. Okay, so it is the man takes, let the man takes t times as long to row up as to row down, then the rate of the man should be x into, this is the short form, look it carefully, x into t plus 1 by t minus 1. Okay, so we have x is equal to 4 and t is gives us, that is t is given as twice, that is the man takes twice time, and you get that is if the man takes t time. So here t means twice, that is t means 2. So here we can put t is equal to 2. Now by putting the values, x gives us 4 and this gives us 2 plus 3 by 2, sorry, 2 plus 1 by 2 minus 1, which gives us 4 into 3, that is 12. This is 12 and also this is 12. So this is the short process of this type of mathematics. Okay, this type of problems. So just look it out carefully before you proceed to our next problem. Okay, now move on to our next problem. Okay, so this is exercise 5, that is problem number 5. So this tells the speed of a boat in still water is 6 km per hour and the speed of the stream is 1.5 km per hour. A man rows to a place at a distance of 22.5 km and comes back to the starting point. Find the total time taken by him. So in this case, we have to find out firstly the upstream speed and the downstream speed. So upstream speed is equal to, okay, our speed of the boat is 6 km minus speed of the stream is 1.5 km per hour, which gives us 4.5 km per hour. Okay, similarly downstream speed gives us 6 plus 1.5, that is 7.5 km per hour. Okay, so find the total time taken by him. So total time, that is 22.5 at the time of upstream speed, that is 4.5, and also total distance by at the time of downstream speed, that is 7.5. So this is so this equation gives us the total time. Okay, so this gives us, if we cancel it, it gives us 5 and it gives us 3, so 8. Okay, so this is our answer. So this problem looks like it's a huge, but it is a very short form. Okay, very short process, very short process problem. Okay, so let's proceed to our next problem. That is, this is our last problem. Okay, so this is our last problem. That is, a man can row at a speed of 5 km per hour in still water to a certain upstream point and back to the starting point in a river which flows 2 km per hour. Find the average speed of total journey. Okay, let me introduce you the detail method. Okay, so let the total distance be x, then average speed we can say that is total distance by total time. So we can say total distance for going up and going down is 2x, that is x plus x, by Total time means at the time of downstream speed, that is 5 plus 2, that is our speed of the man is 5 kilometer per hour and the speed of the stream is 2 kilometer per hour. So at the time of downstream speed, it gives us this one, that is x by 5 by 2. This gives us the first time, at the time when the man goes to the downstream, and the another one, that is the downstream speed, that is x minus upstream speed, that is x minus 5. Okay, so this gives us 2 by x by 7 plus x by 2, sorry 3. Oh, this calls 2. Okay, so this gives us, by solving this, we have 2x into 21 by 10x. Okay, so this is cancelled out by 5. So our answer is 21 by 5 kilometer per hour. So this is the average speed. Now the shortcut method. Okay, the shortcut method is, if the let rate of the man is equal to x and rate of the water, let's say it y, then average speed is equal to x plus y, x minus y by x. So this is the formula. By putting, we get x is equal to 5 and y is equal to 2. Let me put this put the values to the equation, that is 5 plus 2 and 5 minus 2 by 5. So this gives us 7 into 3 by 5 means 21 by 5. Okay, so this comes also 21 by 5, this comes also 25 by 5. This is the detailed method and this is the short form. Okay, just look it out carefully. I will show you slowly. Okay, so that's all.